Hello everyone, my name is Norma Rangel and I talk about the study of absorption process of 3 different pesticides on carbon nanotube applied in Monte Carlo simulation. The pesticides have been found in body of water and are directly related to the poor quality of it. This can reach living beings, causing severe damage to the body. In this situation, it is very important to study new methods for helping minimize this negative impact. In this case, we apply the diron, glyphosate, and atrazine like the principal pesticide. In this sense, the absorption using carbonaceous materials such as carbon nanotube was considered a good option since it has a tubular structure and high surface area for removing several contaminants at the same time. Computational chemistry calculates molecular properties through geometry as well as electronic structure and its energy. Molecular mechanics bases its principle on considering that molecules are spheres that are joined together by a spin. This has a resistance to stretching and therefore there is a change in geometry and energy. Quantum mechanics predicts the behavior of the molecule based on its electronic structure. The method is widely for use in organic compounds compared with the output model 1. And finally, Monte Carlo simulation refers mainly to creating configurations that are representative of a complex system carried out under thermodynamic conditions. The thermodynamic properties of the particle of molecules are obtained from the Hamiltonian and the generation of random numbers, so that is include the quantum effects. Like methodology, we have the optimization process of the different structures. Started the PM3 method since they generate a lower energy structure even when the initial structure is very far from the minimum structure. The polar Riviere algorithm was used for mapping the energy barrier of the conformational transition. For each structure, we applied 13-15 iterations, and in the Monte Carlo simulation allowed knowing a behavior that the measure and each binary system will have as the temperature increase. In this way, the energetic and structural properties for different carbon nanotube pesticides, we applied 20 runs step in a different temperature. Different results include the individual material, and we can appreciate that negative values were obtained in gift-free energy and in a heat formation, indicating that there is a spontaneous and exothermic process as well as a stable molecule due to the negative in energy. Likewise, a dipole moment of 0 is appreciated attributed to the electronegativity of oxygen as well as the presence of the phosphonate and carboxyl group. On diron, the dipole moment was 4.548 attributed to the electronegativity of the carbonyl group and the current present. In atrazine, the dipole moment was oriented to the most electronegative atom, in this case was the nitrogen. On glyphosate, the log P was negative about the 0.56, which was caused by the polarity of the hydroxyl group and the secondary amine that allowed the formation of the hydrogen bond with water. Finally, we can appreciate that in diron atrazine, the interaction with water due to the presence of polar molecules such as secondary amine, which due to its physical property form hydrogen bonds with water, and in the carbon nanotube is hydrophobic due to the sp2 hybridization of the double bond carbon. For that reason, the carbon nanotube has little or no dispersion in water. The result about a different absorption process with the different pesticides, we can appreciate that the energetic property of carbon nanotube pesticides show the absorption was spontaneous and endothermic process. The binding energy reflects the stability of the measure, and the dipole moment is close to 0 due to the distribution of carbon in the entire structure of the carbon nanotube and the oxygen present. And although it's very low value, it's possible that carry out the absorption process. On glyphosate, the increase in mass, volume, and surface area were attributed to the interaction that exists between carbon nanotube and the oxygen on the hydroxyl group of the phosphonate. On diron, the hydrophilic molecules can also behave in a hydrophobic way due to the benzoin ring. For this reason, there is an increase in the value of log P during the absorption. Finally, in atrazine, the positive log P obtained after the absorption was attributed to sp2 hybridization of both carbon in the carbon nanotube and the carbon on ternary amine present, and increased the value due to the fact that both molecules are considered like hydrophobic. And we can appreciate in this in yellow line the oxygen in the hydroxyl group of the phosphonate is susceptible to forming hydrogen bond with the carbon nanotube. In green line we can appreciate that the oxygen or the diron of the carbon nanotube can form hydrogen bonds. Finally, the carbon nitrogen bonds demonstrate the interaction carbon nanotube with the atrazine and the highest absorption capacity was carried in the carbon nanotube glyphosate without the influence of the external factors such as temperature. This is caused by the electron density and is verified by the electrostatic potential map and the different absorption. Although it must be remembered that dipole moment is a function of the share of the distance between atoms. In this slide we can appreciate the different results about the Monte Carlo simulation, and it was observed that in 3 absorption process was spontaneous and endothermic. They are also stable due to the negative value of binding energy. It was also appreciated that dipole moment is a function of temperature, and this phenomenon was attributed to the stimulation that electrons receive as the temperature increases, and consequently the electron density and distribution of share change. Therefore, the absorption of the carbon nanotube at different pesticides is greater in dipole moment of greater magnitude because it's more likely to form bonds or intermolecular force between them. We can appreciate in this slide there is no significant change in structural property since they do not depend on temperature. However, volume and surface area were found to have a little change as the temperature increase new structure developed due to the formation of new active sites on the surface of carbon nanotube, and the absorption capacity of the carbon nanotube pesticide was affected. In this slide we can appreciate a different electrostatic potential map about the absorption glyphosate on carbon nanotube at different temperatures, and the interaction takes place at the hydroxyl of the phosphonate group. In this slide, the diron pesticide was carried with the carbonate group, and both tend to form hydrogen bonds with the hydrogen in the carbon nanotube as the temperature increases. In particular, this phenomenon is attributed mainly to the high electronegativity and the pair of free electrons on the oxygen on this pesticide, and it's the same. We don't see a different change in a molecular structure. Finally, in atrazine absorption in carbon nanotube takes place between the carbon of the carbon nanotube and the nitrogen of the atrazine group about the pp interaction due to the high electron density in sp2 hybridization to the double bond carbon as well as the electronegativity of the nitrogen. In this slide we can appreciate that the absorption of glyphosate and diron on carbon nanotube present symmetric stretching principally on the hydroxyl bond, and by atrazine we can appreciate the principal bond is carbon nitrogen, and the vibrational mode was symmetric stretching too. Finally, like conclusion, we had the absorption between carbon nanotube and pesticide was affected by hydrogen bonding and pp interaction, promoting an increase in surface area, volume, and dipole moment. Specifically, a higher dipole moment indicates a high absorption capacity due to the electron density. It was also observed that the interactions are mainly with increasing temperature, that all absorption processes are spontaneous, endothermic, and thermodynamically stable. The absorption capacity will be affected by the nature of the molecules, since if there are molecules in the mixture that are hydrophobic, they will have the tendency to interact strongly compared to those where hydrophilic and hydrophobic molecules are found that at the same time. Thank you, everyone.